the LeetCode. Hello everyone, it's June the 16th. Happy Father's Day. Sum of square numbers. Given a non-negative integer, decide whether there are two integers a and b such that a squared plus b squared equal to c. Huh. That is interesting. Okay. How many are there? All the way to 2 to the 31st. Okay, I need to use my calculator for this. 2 to the 31st minus 1. If I do a square root of that, is 46,340. Okay, so I have from 1 all the way to 46,340. And I have every single one of them in an array. And then I just go through them one by one. Right? Is that how we're gonna do? Let's give it a shot. Maybe 7. Alright, so what I'm saying is int square equal to new int. Actually, I don't know how many. 46,340 to 41, right? And for int I equal to 0, I actually equal to 1. I smaller than. Okay, so max is 46,340. 46,340, right? Smaller equal to max I plus plus. Oh, I cannot use this. Actually, no, I can. Wait, no, I cannot. No. Wait, do I? I think I can. I just minus 1 and then the remaining we just try to see if the square root is good, right? And we just go through every single one. 1, 2, 3, 4, 5, 6 all the way to the. Yeah? Huh? No, I don't even need this. Alright? Well, basically, int a equal to, we start with 1, right? Because c is 0. C can be 0, so we start with 0, right? And we say while, no. A times A is smaller or equal to C divided by 2. Or we can say 2 times A is smaller or equal to C, right? Well, that, because if A times A is bigger than half, then we already handled it, right? And then we can just say int BB can equal to C minus C minus A times A, right? And we need to do math.sqrt. A double will give you a double, right? So we can do a double BB. We can say int b equal to int this. If b times b is equal to bb, return true. Otherwise, return false. Does that work? Oh, you have to move a forward. Otherwise, a plus plus. Yeah, move a forward. do a few like 0, 4, and 20. Yeah, 25, and some random number, another random number, maybe another random number. Okay, a couple. All right, looks about right. It's 633, and check every possible square from 0 actually, towards towards a value, towards half, right? Towards half of C. Let's see how we go. Maybe some, I don't know, really? I think, oh shoot. I think we, overflowed. Okay, let's try this. I think we overflowed. Lossy, cannot do that. All right, everybody's long. Damn it. All right, long C equal to long C. Now we can just do C, C. Everybody's long. Long. Okay. Overflow is such a thing that I never really got used to check. Yeah, there we go. It's overflow. There might be a mathematics solution, I guess. I don't know, maybe. Note, use long to avoid overflow. Alright, let's take a look. Brute force, yeah, that's exactly what we do. Better brute force. Do you think this is better brute force? This is A, and then this is B. Huh. Yeah, this is what I'm going. Yeah, I have to go long, right? Double B. Oh, look at this. B equal to this. directly go C. I can directly check B is equal to int B. I don't have to. Okay, I can direct check this. Okay. Finally, such. Fermat theorem. I think I remember this. Any positive number n is expressible as the sum of two squared if and only if the prime factorization of n, every prime of the form, occurs in an even number of times. You have to use a Fermat. Jeez. Okay, yeah, that's about it. I'm not gonna implement this Fermat theorem. Alright, so we have to keep doing this one. So what I realized yesterday is, yeah, it's not right. The way that I'm thinking about it is not right because it could be other. So yeah, hold on. When I say it's not right, but we still need to do this, right? In this case, it'll be a true, a false, a true, and a true, right? And then I was thinking, because if it's 1, right, we can include this, and we need to include this thing as well. So depending on the length, but the thing is, it's very long, right? So if we do we can record indices, right? So in this, not count good, but just indices of good, like 0, 2, and 3, right? And then we start, so we need some, right? If we need 2, okay, so we get that. And then anything on the left, anything on the right need to be included, right? Need to be included. So basically, we need to have a -1 in the front, and then the total length at the end. So the number in between will be this minus this plus 1. No, this minus this minus 1, right? 3 minus 2 minus 1 is anything in between, and it's going to be this and this times this. Right now we move on to the next round. We do this again until we hit the end. And then we'll do it again with a bigger one, and then we'll do it again with a bigger one. And with 0, right? With 0, so we don't have a range. And with 1, we only have 1, and then we also check. Now with 0, we simply just finding this part, finding this part, finding this part, finding this part. Okay. Yeah, so let's give this another shot. Actually, it's not what I have in mind. So it's not count good. So we don't do this, don't do this, don't do this. Good indices. Okay. So this, if modulo is equal to k, good indices, got a pen I. And we delete all this. Actually, we'll just delete everything, right? Okay, so now we're done. We're gonna do the length, right? So current length, we'll start with k. Okay, we say while current length is smaller or equal to good indices, right? Because if it's more, then we cannot do. If current length is equal to 0. Actually, I want to do this separately, right? If current length is equal to 0, then we need to go through this. Actually, no. We need to do a -1, right? And at the end, we need to good indices dot append length nums at the end. Okay, so if it's 0, then we need to find all the gaps, right? So we start from, let me say for I in range 1 to len good indices -1. Okay, so we go from there. For each one, I check to the previous, and the rest equal to 0, right? So we check with the previous, and
chalk is out.
sorry. Awesome. Alright, so we go from this, and then we just check the gap, right? And then we have the count equal to good indices I minus good indices I minus 1 minus 1. That is the total number in between. And then rest will plus equal to, I remember it's count times count plus 1 divided by 2. So this equal to 0. And then once we're done, current length will plus equal to modulo. Right, because we do 1 modulo times k, right, and then length could be, times 1 modulo, yeah, so that. And then we go here, we don't have to do this. Then it's basically, we again go from, we need to have current length, right? So what we're gonna do, we'll all have basically two pointers, right? And then we can say, again, for I in range, current length. So if I need, let's say length is 2, so it'll start from current length, right? Or start current length. If length is 3, 0, 1, 2, 3, we start from there, alright? We start from there, and then we do that all the way towards the end. So in range, current length, all the way to line good indices minus 1, right? For each one, let's say left equal to I minus current length, I minus current length plus 1, right? So if it's a 0, 1, 2, 3, and the starting position is 3 minus 3 plus 1 is 1, right? So we do that. We need a j, unfortunately. So j equal to I minus current length plus 1, right? And then what we can do is I do j and it's left. Well, it depends if it's a 0. If it's a 0, we don't do anything, right? If it's a 1, ooh, interesting idea. If we have 1, on the left, or compared to we don't have 1 on the left. If we have 1 on the left, then we have actually 2 choices, right? So you think about this one, if I have this, right, if it's 2, I can do this or I can do this, right? So the count is actually different. So I have this would be, this is j, right? This is actually j minus 1. So I need to count the number in this plus 1. So it's going to be whatever this minus this, right? So this will be 0, 1, 2. So it'll be this minus 2. Yeah, just this minus this.
You're going crazy.
Our cat is going crazy. Hello. Yeah, we can just do this in this index minus this index, and I got this, and then plus another one. Okay, so it's actually make it easier. So I would say res plus equal to basically good indices j, right, minus good indices j minus 1, right, and multiplied by good indices I plus 1 minus good indices I. So it's the gap, because the gap can put in. So we'll do that. And once we're done, current length will plus equal to modulo again. And we'll keep going until we return rest. Alright, let's try this one. Let's give this one a shot. So yesterday was wrong. How many test cases? I only used 1. Okay, let's see if this one's right. Okay, this one's good for this. Oh, I haven't submitted yet. How about this one? Okay, looks good for both. Maybe we can write something for this. Alright, so obtain the indices of all the numbers in nums that mod modulo equals k, right? Then we can count, right? Then we can count the number of subarrays in this good indices array, right, with a given length, Now the subarray in good indices must be how do I say? Now we can count the number of subarrays in this good indices with a given using sliding window. Using sliding window. This has to be mentioned. Using sliding window. We need to include the non-good numbers at both ends of the subarray, right? To count extra possible subarrays. I don't know if I explained it well. Right, for example, if we have bad, and is a good f true f, right? And the subarray length is 2, right? The total number of good subarrays is 2 plus 1 times 1 plus 1, right? Equal to 6, because you have 3 possibilities on the left, 2 possibilities on the right, so it should be like this. Again, what's the runtime for this? I have no clue. This is on. This is, call it on. This I don't know. Well, this actually should be, depending on how big, oh, we call it on. Okay, we can probably call it on. So let's call it on. All right, let's see if this one works. All right, let's run the test case one more time. Looks good. All right, let's see if this is good. Oh, no. Took a long time to judge. Yep, probably not right. Either timeout or it's just not right. Okay, that's fine. Let's take a look. 7 and 2. Output 0 should be 1. Okay, what case that we did not consider? We have 7, 2. Okay. And modulo is equal to 7. And k is equal to 0. Except 1 is 7 by itself. Okay. Wait, hold on. Modulo is k is equal to 0. Oh yeah, it should be here, right? It should be here. Did I not consider this? Right, current length is 0. Right, for I is 1 to this. And I do I minus that is right. This should not be minus 1. Because we are, this should be minus 1 because we have this plus 1. But this is not. This is not. Because this we need to, this is trying to find the total number of this is trying to find the total number of bad ones, right? So it has to go to the end in order for me to do this. But this is different. Okay, try it again. There's a little bit error there. Oh. Okay. It's gonna turn into one of those. Oh, it's actually correct. Okay, it is correct. It's just timed out. Damn you, man. Alright, so this is correct, but we time out. Lord, this is tough. It's TIE. Yeah, it's definitely not ON because this is for every time I have to go through this. Yeah, this is definitely not ON. It's maybe we can call it ON squared, right? So we have to make this one better. This is okay. So this, right? Considering the length, can we make this better? Can we make this faster? So what I'm saying is I have this, right? I have something, something, and then good, good, something bad, something good, something bad, right? And then what we're saying is if we want to count, let's say k equal to 2, right? So we need 2, depending on modulo, what modulo is, but let's say modulo is 2. Okay, let's say modulo is 2. I just use this, right? Oh, Jesus. This is, man, I can't even see. 2 and 1. Right, 2 and 1. So, modulo is 2. K is 1. Oh, Lord. K is 1, so we can do 1. And then, yeah, you start from 1. So 1, 3, 5, da 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 da. And every one you have to go through the whole thing. Every one you have to go through the whole thing. Yeah, that's not happening. That is not happening, man. That is not happening. And this is exactly because one is bad, one is good. So we basically have a this, all the way to the end. I don't know what's the last one. And then we say we want 1, and then we want 3, and we want 5. Holy crap. Or is it possible DP this? Like when you create this good indices array, can we DP this thing? Like what do you mean by DP this thing? Because I need to count, right? I need to count starting from k and a modulo plus k, right, up into some, like, how many in total? How many in total? But if you think about it, for each, so this is, I'd say, this is a good indices, okay? This is a good indices. I have G0, G1, G2, all the way to I don't know, GK. Let's say GM, okay? And I know we have -1 at the front, and we have n at the end. So for every 1, okay, so for every gx, I have a left value and I have a right value, which counts the number of bad, right? The number of bad on the left, the number of bad. For everyone, I have this. Therefore, the count is going to be, given the length, right? I have, because the length from G0 all the way to G, let's say length is C. Okay, C is the current length. So it's going to be to GC -1, right? Because from G0, if I want length 2, it's going to be these two. And then all I need to do is, I call this L and R. Okay, so this is going to be L and R. But keep in mind, this R is equal to this, right? It's just the gap, the count, the gap count. The gap count. Let's do some gap count as well. Okay. So let's call it this count 0. Okay, count 1, count 2, all the way to, this one will be count m, and this one will be count m plus 1. Alright, so this will be G0, so it'll be count 0 multiplied by whatever this is, the next one, so it's count C. Don't use count. Let's use P. Okay, so P. Count is the length, right? So P0 to PC, right? And then we're going to be this plus P1, PC plus 1, P2, PC plus 2, all the way to P, I don't know, the last one, right? P something and PM plus, well, actually we can count because 0C plus C, right? So it would be M plus 1 minus C. So we'll do this bunch, right? That will be the first. Then we'll have a new length, which is C plus modulo, right? And then it's going to be P0 times P C plus, oh, I cannot use M, mod, right? C plus mod plus P1 times P C plus 1 plus mod all the way to P also M plus 1. It's going to be PM plus 1 minus C minus mod, right? And then we're going to do 2 and we do 3. So essentially we can do all the way. Let's say we can get C plus, oh my dear me, we need another one, Q. Okay, Q times mod. Okay, Q times mod. Then it will be very interesting, right? So we can say if we want to add all these together, it's gonna be, you know, PC plus mod plus PC plus mod times 2 all the way to, you know, whatever. And the next one will do the same. Next one will do the same. Next one will do the same. And so what? Right? So what? And each one they multiply. So if I can find like the sum of this, maybe I can, right? I can, because it's basically, we start from the first gap, right? P0, well, times PC, which is actually, don't call it C, right? I don't like to call it C. It's actually not C. This is actually K, okay? This is not C. This is actually K, right? This is actually K. And this is K plus mod. This is K plus this, right? So this is going to be times PK, right? PK, PK, this is all K. These are all K. Right, this is going to be PK, because we're going to add these together, right? Plus PK plus mod, plus PK plus 2 mod, plus I don't know, plus until I cannot plus anymore, right? This I can do. Can I? I think I can do this. Because it's, you know, it's equal gap, right? The gap length is the same. So I can compute what the last one is going to be. Right? I know what the last one is going to be. Right? I know what the last one, because the last one is going to be K plus some mod that will not go beyond what I have. And I can do, but then you have to, but the thing is, once you do this, right, and then when you do P1, it's going to be P, you know, K plus 1 plus, so these are not the same. So you can do this all by itself, right? You can, because it's skip. And then you do this all by itself. You do the next one. You do everything all by itself. Interesting. That is literally interesting. So the overall will be ON, because you are not repeating anything. Okay. I think that's an interesting idea. I think I want to pursue this idea. And actually, no, even with the 0 we can do, because we're not doing these. We're taking the P's, we're taking the gaps, we're getting the gap value, right? Because that's what we're interested in. We're taking the gap value. Very cool idea. All right, I'm not doing this today. I'll come back to this tomorrow, but this is a cool idea. Alright, I will